In this video, we will be discussing multiplying radicals. So I have 7 examples that we'll go through. The first 2 are just multiplying 2 individual radicals. And then you can see that as we move forward, we have a distribution property one. We have some where we're using multiple distributions or FOIL. And so we'll talk about the techniques for each of these. So in number 1, you can see that we have the square root of 3 times the square root of 7. When we add radicals, we have to have like radicals. So just a reminder, let's say we wanted to do something like, like that. We can add these because they're like radicals, and we would get 4 square root of 2 because we're adding the coefficients 3 and the understood 1 to get the 4, and then the 2 stays the same. That's when we're adding. We could not add, let's say, square root of 3 plus square root of 6. We could not add these because they're not like radicals. But for multiplying, you do not have to have like radicals. You just multiply them together. Now, they still both need to be square roots, or they still both need to be cube roots. So if you look at number 1, there's nothing written there as an index, which means they're both square roots. So you can multiply, but the numbers under the radical do not have to be the same. So if we want to multiply the square root of 3 times the square root of 6, we can do that, and you simply multiply the two numbers under the radical together. So 3 times 6 is 18, so this would be the square root of 18. That's the multiply step. It's as simple as that. Don't forget to simplify your radical. So the 18, you can either put this in your calculator, the square root of 18, and let it simplify it for you. Perhaps you have a calculator that will do that. If you don't have a calculator that will do that, or you're not allowed to use your calculator, you can simply do a prime factor tree. So any two numbers that multiply to get 18, 9 breaks down into 3 and 3. All the numbers at the ends of the branches are prime. Any pair will come out of the radical, and the single will stay under. So the 3's come out as a 3, and the 2 stays under the radical. So the square root of 18 simplifies to 3 times the square root of 2. So this is the product, 3 square root of 2. Number 2, it looks a little different, but they're both square roots. You can multiply these. What you do is you multiply outside with outside and inside with inside. So 3 times 2 gives you 6, times the square root of 7 times 5 gives you 35. On the previous one, we really did the same thing. If you notice, outside with outside, there's nothing there, but it's understood to be a 1. And 1 times 1 would give you the 1 out front. And then the 3 times the 6 is where we got the 18. We're doing the same thing here. 7 times 5 underneath the radical gives us 35. And the 3 times the 2 on the outside gives us the 6. You should make sure that you can't simplify the radical. 35 is 5 times 7. Both of those are prime. There are no pairs. So you can't simplify the radical any further. So 6 times the square root of 35 is our product for number 2. For number 3, we want to distribute this negative 2 in the parentheses. So negative 2 times 2 square root of 3. Notice that the negative 2 is not under a radical. So you would be multiplying that by the 2 that's on the outside, not the 3 that's underneath. So the first part will just give us negative 4 square root 3. And then negative 2 times negative 5 is plus 10. Now you may be tempted to combine these together and say, oh, this is 6 square root of 3. Not okay. Remember, to add, you have to have like radicals. The negative 4 is attached to that square root of 3, and 10 does not have a square root of 3 attached. So those are not like terms, so you cannot add them together. So this is it. This is where you stop. Number 4, I'm going to be distributing that square root of 3. So if I distribute that, 2 times the square root of 3. Now, a common mistake is you would say square root of 6, maybe. But notice that the 2 is not under a radical. It's just a whole number. But 3 is under the radical. You're multiplying that 2 times the understood 1 coefficient. So remember, you have to multiply like with like. Outside with outside, inside with inside. So this is going to be 2 square root of 3. And then the square root of 3 times negative 6 square root of 3. That's going to be negative 6 square root 9. Well, the square root of 9 is 3. So that's going to be negative 6 times 3. The 3 is not under the radical anymore, remember, because we took the square root of 9. So then we have to multiply the negative 6 times 3. So 2 square root of 3 minus 18. Again, we can't go any further than that because those are not like terms. So that's it. Number 5. So 3 and 4, we're both just distributing one thing to the parentheses. 5, 6, and even 7 are going to be more of the FOIL technique or multiple uses of the distributive property. So let's start with the number 5. The square root of 2. So we'll do square root of 2 times square root of 3. That's the square root of 6. Square root of 2 times 1. That's just going to be square root of 2. I've used that one. Now I'm going to do the negative 5. So negative 5 times the square root of 3 is negative 5 square root 3. And then negative 5 times 1 is negative 5. Now we want to look and see if we can simplify any of the radicals. 6 will break down into 2 and 3, but there's no pairs. 2 is prime, 3 is prime. So there's nothing I can simplify here. There are no like terms. So this is it. So that's it for number 5. Let's look at number 6. We have 3 times 3 is 9. 3 times 2 square root of 2 is 6 square root of 2. So we've used the 3. Negative 2 square root of 2 times 3, that's going to be negative 6 square root 2. And then negative 2 square root 2 times 2 square root 2. So the outside 2's multiply together to get 4, and specifically negative 4 because they have opposite signs. And then the 2's underneath will give you a 4 under the radical. Notice the middle two terms are like radicals, but they're opposites. I have a positive 6 square root of 2 and a negative 6 square root of 2. So those are going to zero out. The square root of 4, well, that's just 2, so that will come out of the radical. So it'll be 9 minus 4 times 2. So that's going to be 9 minus 8, and that's just going to give us 1. Notice that we got something a little bit simpler, right? Well, this case, really simple is 1. But when you multiply these two things, these things are called conjugates. And conjugates, you'll end up getting rid of all your square roots. So if you have, and this is how you identify conjugates, they both start with a 3, they both end with a 2 square root 2, so they have the same numbers. The same numbers first and the same numbers second. The only difference is the signs are opposites. So these are conjugates. And when you multiply conjugates, you end up with no radicals left. So all the radicals end up going away because the middle two zero out like we saw because they're always going to be opposites. And then the last term is made up by multiplying something times itself, meaning you're squaring it, meaning you get rid of the square root. So what happens is when you multiply it, whatever's under the square root in this last term will end up being a perfect square. So your square roots are going to disappear from these when you multiply conjugates. Number 7, this is the last example that we'll do. remember that you cannot do this. So common mistake is that people are like, oh, I can just distribute this little 2. And they say it's 36 minus the square root of 11 squared. So that's 36 minus 11, 25. That'd be great if that was how you do it, but it's not. Remember that when you're squaring something with a minus or a plus inside, you cannot just distribute the little 2. So you can't use a power rule over subtraction. So what you have to do here is remember what this means. This means 2 of these things. So you can avoid making a mistake by writing it twice and then just foiling or distributing like we did for 5 and 6. So if we do that, we'll get 6 times 6, so that's 36. 6 times negative square root of 11 is negative 6 square root of 11. Negative, oh, I used that one. So negative square root of 11 times 6 is negative 6 square root 11. And negative square root of 11 times negative square root of 11 is plus square root of 11 squared. So I could have said square root of 121 and multiplied the two 11s together, which would be fine. Or I could recognize that I'm just squaring it. I have the same thing. So when you multiply something by itself, you can just say it's that squared. Either way, it would be fine. Remember that the square root and the square are inverse operations, so those undo each other. Make sure you realize that the middle 2 are like terms, but they don't cancel out this time because they're the same sign. So they're just going to add together. So we will have 36 minus 12 square root of 11 plus 11. And then we can combine the 36 and the 11 because those are like terms. So that would be 47 minus 12 square root of 11. Again, we cannot go any further, so don't make the mistake of subtracting 12 from 47 because 12 is attached to the square root of 11, and those are not like terms. So that would be our answer for that one.